So welcome to the next subtopic of astrophysics, 8.1, orbital speeds. We learned about orbits last topic. Let's learn about the speed of those orbits. So there's two learning objectives. There's one with a know that objective, so they've got to know three things there, which we'll go through. And then we've also got to use that mathematical relationship there about orbital speed, which is the next slide. So orbital speed is basically the speed of an orbit, makes sense. And it equals 2 pi divided by the orbital radius. So the orbital radius is going to be the radius from the center of the object that's being orbited to the object that is orbiting. And that orbital speed is in meters per second because it's speed. The orbital radius is in meters and the time period will be in seconds. And one important aspect of orbital speed is the idea of geostationary satellites. So geostationary satellites basically have the same speed as the spin of the Earth, okay? So it ends up being the same place above the Earth as it orbits around it. And so basically the three kind of things about orbital geostationary satellites is they take 24 hours to complete their orbit, just like the Earth does. They have to be in the same direction as the orbital spin of the Earth, okay? So they stay in the same place. And they have to be above the equator. Okay, and just another thing, they orbit about quite high up, about 36,000 kilometers up. And they're used for a variety of things like TV, weather satellites as well, testing nuclear explosions, military satellites. They're all kind of around, they're geostationary satellites. Telecommunication satellites as well for our mobile phone technology. So in terms of our position in the solar system and our position in space, we belong to the galaxy known as the Milky Way, okay? And it's a very beautiful thing to see if you see it in the night sky. So if you're lucky enough to be in a place which has not much light pollution, like down south in New Zealand or the Atacama Desert in Peru, which I recommend, it appears as a cloud which represents, basically looks like spilt milk has been spilt over the night sky, hence why it's called the Milky Way. And that's a wonderful image there showing its beauty. Well, I think it's beautiful anyway. And in terms of galaxies, what are galaxies? Well, galaxies are billions and billions of stars bound together by the force of gravity, which we've already looked at in the previous topic. And there's thought to be about 200 billion galaxies in our universe, and each contain around about 2 billion stars. And you can see our position in the Milky Way galaxy by looking at the image below. We're kind of on the middle of a swirl in the swirl galaxy of the Milky Way. That's where we are. You are here. So there's 4 types of galaxies. There's the spiral galaxy, the whirlpool galaxies. There's the barred spiral, NGC 1300 is an example of that, but also our own Milky Way is an example of a barred spiral galaxy. And then we have the elliptical galaxies like M32, so this giant conglomeration of stars. And then we've got the, we can't fit it into any other kind of shape, the irregular shapes like the small Magellanic Cloud. Again, if you Google these images on Google, on the internet, they're beautiful images. Yes, so that's basically what we're looking at today. So we've gone through types of galaxies, solar system, and also gravitational speed. So we'll work on those kind of questions around that in class.